Welcome to clickmyproject.com. Now we discuss about the product for a new clustering based routing algorithm for NoC. Next we see the abstract for the product. By the end of decade, according to the International Technology of Roadmap for Semiconductor, SoC will grow the 4 billion transistor running at 10 GHz and operating below 1 volt. Typically in these systems, several complex heterogeneous components can be integrated such as programmable processor, memories, input-output interfaces, custom hardware, peripherals, external interface, intellectual property blocks that need to communicate with each another. One of communication architecture that serves of interconnection fabric for communication between these components. These elements serve to increase the performance and to reduce the cost for improve the energy efficiency. Several architectures based on bus communication have been proposed for previous methodology. This NoC is a new paradigm based system on a chip. This technology is come to replace the classic buses interconnection to interconnect the IP module in SoC designs. The most important aspects that distinguish the various NoC architecture are topology and routing algorithm. After determining the network topology, the routing algorithm is the responsible of deciding the path a message or a packet will be take through the network of to reach the destination process. With the increasing the number of integrated cores on a single chip, research into the network on chip becomes important. NoC has been proposed a solution to replace the classic interconnection of a system on a chip design. Topology and routing algorithm are important keys of NoC design. In this paper, we propose a new fault-tolerant routing algorithm for a network on chip. This proposed algorithm based on communication between the dynamic routing algorithm and the communication of load clustering technique in a 2D mesh topology connectivity. Next we see the flow diagram for the product. First the source to apply our data bits into the source router positions, then to calculate the topology connectivity for overall routing designs, then to assign the router for routing designs for overall forecast for routing architecture design, then to clustering algorithm. The clustering algorithm mainly to fabricate the hop to hop communicate for the each and every routing configurations. These routing configurations separately based on separate clustering based methodology. This cluster to identify the same for the different groups and to identify the same process and to transfer the data into the same processing data. Just the hope for the same processing element. These all routers data to be placed for the hope element, then the hope to hope connectivity to pass the topology based connectivity, then the detailed routing based on the what are the selection based process to be applied for the hope selection, and to hope to transfer the data into the source to destination process. Then the global routing means to be identify the hope connectivity, then to transfer the data for secured path details about the source to destination, and to do not identify the another routing positions for the clustering algorithm. This is the overall flow or the source to destination for clustering based routing algorithm for NoC architecture designs. And finally we see the output for the product. First we run the global NoC for the SGC project, then open the program for NoC architecture. This program was developed in VHDL language, and to apply the structural modeling process for developing the VHDL language in our global NoC architecture designs. Then to select the simulation process and to select to run the simulate behavior model, then to open the iSIM project navigator. This navigator mainly used to simulate our the overall processing results. Just we apply the binary data input for NoC architecture and to get the output data due to the hope to hope connectivity for source to destination architecture. Then to apply the clocking, clock the input and to select the reset function to deactivate the output results for overall functions. Then to address apply to the store the data results for routing architecture result. Then to activation for the writing and reading control for WR and WR1 to WR2 signal level. Then to apply the any type of binary data for NoC architecture for north, south, east, west input side. Then to run the time specified on the toolbar and to activate the clocking signal and to apply the processing results for overall architecture. Then to run the clocking signal and to deactivate the reset function for overall architecture. Then to run for the time specified and to apply the clocking signal based on our flowing process for overall architecture results. This is our 8 clock pulse based on our writing activation line to the transfer the position for overall processing architecture, then to apply the clocking signal for overall simulation process. These are the processing results for overall architecture results. Then to run the simulation process and to select the implementation work, then to select the view RTL schematic. This RTL diagram to represent see what are the logical blocks placed in our overall architecture designs. This is hope analysis and to the central router for 3 position cluster based router. This is our selection logic for overall NoC architecture design. Then to go to the technology diagram. This technology diagram, what are the lookup table, input output buffer connections and the flip-flop storage element for overall architecture result. Then go to the design summary process. The design summary process mainly used to reduce the hardware complexity designs and check the device utilization process to reduce the hardware complexity result for overall architecture results. Then go to the timing summary process for NoC design. This is our timing summary level. This is the minimum period and the maximum frequency for clock speed. Then the latency count for before and after clock of LUT function running for overall architecture process. This is our latency time and to reduce the latency time and improve the system performance for overall NoC architecture designs.